welcome to the new section. My name is Gautam Aduri, and this is the last section, a closer look at machine learning. So it's time to take a closer look at machine learning. In the last module, I want to talk about machine learning concepts in somewhat more detailed way. I also want to use a terminology that a machine learning person would use. So we are going to talk about training data, and we are going to talk about two different types of learning: supervised and unsupervised learning. And we are going to look at how we classify machine learning problems and algorithms. I will discuss training a model, which actually means something very simple, as you will see. We will look at testing a model, and then finally we will talk just a little bit more about using a model. So I will. So these are the concepts. I'm going to discuss it in a more detailed way in this module. So coming back to the terminology, the first thing we need to walk through is some terminology. Like most fields, machine learning has its own unique jargon, which you must understand. So let's start with the idea of training data. Training data means the prepared data that is used to create a model. So rather than the prepared data, I will come from now on to refer to the training data. Why it's called training data? Because in the jargon of machine learning, creating a model is called training a model. So training data is used to train to create a model. Also, there are two broad categories of machine learning. One is called supervised learning, and the other and categories of machine. And what it means is that the value you want to predict is actually the training data. So you can able to this is like a predictive machine learning. I can say for instance, in the example I have been using data for predicting credit card fraud, whether or not given a transaction is fraudulent is actually contained in each record. The data in the jargon of machine learning is labeled. So we are doing what's called supervised learning when we try to predict whether a new transaction is fraudulent. The other kind of thing is called unsupervised learning, and here the value you want to predict is not in the training data. The data is unlabeled. Both approaches are used, but it's fair to say that most common approach is supervised learning. So we'll see some of the main data pre-processing with the supervised learning, how we pre-process the things. So the machine learning process which starts with data. So it might be relational data, it might be from a NoSQL data, or it can be from a Hive or Blob, or it might be a binary data. Wherever it comes from, though you need to read this raw data into some data pre-processing modules, typically chosen from the things your machine learning technology provides. You have to do this because raw data is very rarely in the right shape to be processed by machine learning algorithms. As I said earlier, you'll spend lots of time, so often the majority of the time in a machine learning project on this aspect of this process, like getting the data from different data sources and pre-processing it. So at this stage, you'll spend most of your time. For example, there may be holes in your data, missing values or duplicates, or maybe redundant data where the same thing is expressed in two different ways in different fields, or maybe there's information that you know will not be predictive. It won't help you to create a good model. You want to deal with all these issues. The goal is to create training data. The training data, as we saw in my simple example earlier, commonly has columns. These columns are called features. So for example, in the simple illustration I showed data for credit card fraud, there were columns containing that card was issued and the country card was used it and the amount of the transaction. Those are all the those are all the features in the jargon of machine. And because we are not talking about the supervised learning, the value we are trying to predict is whether the given transaction is fraudulent. It is also in the training data. In the jargon of machine learning, we call that one as target value. So these are called features, whatever the transaction, and whenever you want to find whether the credit card transaction is fraudulent or not, what are the final value that you're going to is called the target data. And training data is nothing but the supervised learning data. And categorizing the machine learning problems, it's common to group machine learning problems into categories. So there are a lot of categories, but three of them show up awful a lot. One of them is category is called regression. The problem here is we have data and we would like to find a line or record that best fits the data. Regression problems are typically supervised learning scenarios, and an example question would be something like how many units of products will sell next month. So how many units of this product will sell? So it's like a predictive type of thing. And a second category is called classification problem. Second category of machine learning problem is called classification. Here we have data that we want to group to classes, at least two sometimes more than two. When new data comes in, we want to determine which class the data belongs to. This is something commonly used with supervised learning. An example question would be something like, is a credit card transaction fraudulent? The example I've been using throughout this course fits here, because when a new transaction comes, we want to predict which class is it in, fraudulent or not. And often you will get back what you will get back is not yes or no, but a probability of which class this new transaction might be in. And a third category of machine learning problem is commonly called clustering. Here we have data and we want to find clusters in that data. This is a good example when we are going to use unsupervised learning, because we don't have any labeled data. We don't know necessarily what we are looking for. An example question here, something like, what are our customer segments? We might not know those things upfront, but we can use machine learning, unsupervised machine learning, to help us figure that out. And these are the different styles of machine learning algorithms. The kind of problem that machine learning addresses aren't the only thing that can be characterized. It is also useful to things about the style of machine learning algorithms that are commonly used to solve the problems. For example, there's the decision tree algorithms. These are algorithms that uses neural networks in which some ways emulate how the brain works. They are neural networks. They are Bayesian algorithms that uses Bayes theorem to work up probabilities. They are k-means algorithms that are used for clustering, and there are lots more. The details of these are way outside the scope of this course, but having some broad sense of what styles is certainly useful for this course. And the next one is training and testing a model. So training a model with supervised learning. Let's take a closer look with the process of creating a model and training a model. We start with our training data, which we worked with until it's beautiful, pristine, just what we need. Because we are using supervised learning, the target value is a part of the training data. In the case of credit card fraud, in the case of credit card example, for instance, the target value is whether the transaction is fraudulent or not. Our first problem is to choose the features that we think will be the most predictive of the target value. For example, in the credit card case, maybe we decide that the country in which the card was issued and the country which it's used in the age of the user, are the most likely features to help us predict whether it's fraudulent or not. We have chosen, let's say, features 1, 3 and 6 in our training data. We have chosen features 1 and 3 and 6 in our data. We then input the training data into our chosen learning algorithm. But notice this, out of these 6, 1, 2, 3, 4, 5, 6, 7 features, we are choosing only 3 features out of this. So 75% of data all chosen. Why is that? I'll tell you in a minute. But first think about this. How do we decide which features were most predictive, and how do we choose learning algorithm? There are lots of options we have seen. The answer is, if it's a simple problem, or if it's maybe our technology is simple for machine learning, the choices can be limited or not too hard. If you have more complex problem, though, with lots of data, more powerful machine learning technology, with lots of algorithms, this can be hard. If we have, for example, training data that has, I don't know, about 100 features, I have about 200, which ones are predictive? How many should we choose? 5, 10? Or the answer is, that's what data scientists are for. That's why people who have knowledge and facility with these technologies as well, domain knowledge about some particular problem, are so valuable. It's because they can help us to do this. It can be a hard problem. In any case, the result is to generate the candidate model. The next problem is to work out whether or not the model is any good, whether this supervised training the model is good or bad. So now we we do that in supervised learning like this. We input test data to a candidate model. The test data is the remaining 25%, and the data we held back for the features we are using, in this case 1, 3 and 6. We use that data because our candidate model can now generate target values from the test data. And here the thing, we know that this target value should be, because they are in the training data. All we have to do is compare the target value produced by our candidate model from the test data with our real target values, and which are in the training data. We have to compare these values, compare the target values produced by our candidate model. Whatever the candidate model is produced from the test data with the real target values. Whatever the real target, we just have to compare with the features the training data and with the test data. That's how we figure out whether or not our model is predictive and or not when doing supervised learning. Suppose it's not. Let's improve our model with some options. Suppose the model is just not very good. How can we improve it? Well, there are some usual options. One of them maybe improve. One of them maybe we have chosen the wrong features. Maybe choose some other features 1, 2, 5 this time. Maybe it's the case we have chosen the wrong data. Let's get some new data, or at least some more example data. Maybe the problem is the algorithm. Maybe in the case we can modify some parameters in the algorithm. Maybe that's the case we can modify some parameters, they commonly have them, or choose another one entirely. Whatever we do, we generate another candidate model, we'll test it, and the process repeats. It iterates. No, iteration is a fancy way of saying trial and error. So don't be confused. The process is called machine learning, but notice how much people do. People make decisions about features, but about algorithm, but the process is very human. Even though it's called machine learning, but all we are doing is we are trying to predict the data, and we are trying to create an algorithm for the machine learning, and we are trying to create a training data, and all these things are being done by the human being. And using a model, so how we can use a model? There's one last thing I want to talk about using a model. In some ways, this is the most important topic, because you need, until models are used, they don't really have much value, because from the model only we can use, and we can use for the application to predict whatever the value, if the credit card transactions are fraudulent or not. So until we create the final model, there's no value to this machine learning scenarios that we are creating it. An application, for example, can call a model providing the values for the features, and the model requires, and remembering the models can make predictions based on the features that we have chosen, and when the model was trained. The model can then return a value predicted using these features. The value might be whether or not actually it's fraudulent, estimated revenue, a list of movie recommendations, or something else. The point here is the machine learning can help people create better applications. So you can create better applications by using the final model, whatever you are doing it. And that's it. Let me end by summarizing some key points. First, machine learning has come of age. It's no longer some technology that's only for researchers in faraway labs. Machine learning isn't too hard to understand. I hope you agree after watching this, although it can be hard to do well. Finally, I said this before, I want to say it again, because in some ways it might be the most important thing I make in this. If this machine learning can help you to generate good knowledge on the machine learning algorithms, and also can probably help to your organization. Thank you for watching. Have a nice day.